The US has a labor force of 250 million. Mexico has a labor force of 100 million. Both countries are producing two goods, manufacturing and agriculture. Mexico's unit labor requirement in manufacturing production is 5, and in agriculture it is 1. The US unit labor production in manufacturing is 3, and in agriculture it is 2. We want to take these data and put them in a table so that we understand what we're looking at. So what we need to do is to take the 6 numbers we have, the 4 input-output ratios, which are 5, 1, 3, and 2 respectively, and the 2 quantities of labor, 250 million and 100 million, and put them in these 6 spaces right here. Before I proceed with this particular problem, and the answer should be straightforward to some of you, I'm going to move on to an alternative problem. In this particular problem, I have 2 countries, country A and B. I have 2 industries, soybean and textiles, and here's my labor force, and here are my 4 input-output ratios in the 2 countries. It's important to be able to look at this table and interpret what the data are telling us. For example, the 3 here in the first cell would say it takes 3 units of labor to produce 1 unit of soybean in country A. It takes 12 units of labor to produce that same quantity of soybean in country B. It takes 4 units of labor to produce 1 unit of textiles in country A. It takes 6 units of labor to produce 1 unit of textiles in country B. Country A has a labor force of 12,000. Country B has a labor force of 9,600. The first thing I want to do here is to determine the maximum quantities of soybean and textiles that can be produced in each country. This would put us on what economists call the efficiency frontier, the maximum quantities you could produce. So we would see that if we were only producing soybean in country A, because it takes 3 units of labor and we have 12,000 units of labor, 3 goes into 12 4 times, 3 goes into 12,000 4,000 times. So if we took all the labor we had, put it in soybean production in country A, the 12,000 units of labor could produce 4,000 units of soybean. It should be pretty straightforward to see how the other 3 numbers come about. 12,000 divided by 4, 3,000 for textiles. 96 divided by 12 is 8. So 9,600 divided by 12 is 800 for B. And 6 goes into 96 16 times, so 6 goes into 9,600 1,600 times. The maximum quantity of soybean we can have in country A is 4,000. The maximum quantity of soybean we could produce in country B is 800. The maximum quantity of textiles that can be produced in country A is 3,000. The maximum quantity of textiles that can be produced in country B is 1,600. These data are derived from these 6 numbers right here by dividing the quantity of labor by the input-output ratios, and that's what we get as the maximum quantities. Obviously, we understand that this is with specialization. If you only produce soybean in country A, you can get 4,000. If you only produce textiles, you can get 3,000. If you took half of the labor and put it in soybean, you can get 2,000. If you take half of the labor and put it in textiles, you would get 1,500, the midpoint of this particular line, and I'm going to show you how we would proceed. Economists call this a production possibilities curve, right here, or a production possibilities frontier. So it's either labeled as a PPC or PPF, production possibilities frontier. Frontier because it's as far as you can go in producing these particular goods in any linear combination. So the production possibilities set is all of the production possibilities in this set. The production possibility frontier is the frontier of the production possibilities, the maximum you can do. In terms of the trade-off, you can get 4,000 units of soybean and no units of textiles. You can get 3,000 units of textiles without producing any soybean, and the midpoint I mentioned earlier would be at, say, 2,000 units of soybean, 1,500 units of textiles. Draw a similar production possibilities set. We call the line the frontier. Production possibilities set and frontier for country B. joining the 800 units of soybean in specialization to the 1600 units of textiles in specialization. The midpoint, if we were interested in that point, would be 400 units of soybean and 800 units of textile. So here we look again at the quantity of labor in each country and the input-output ratios. Here we have our production possibilities frontiers, and with the frontier joining the corner solutions, which is specialization, I can also determine the midpoints, which would be half of the labor force in each industry. You should be able to observe from these two production possibilities frontiers that country A can produce absolutely more soybean than country B, and likewise country A can produce more textiles than country B. A typical test question is, since country A can do everything better than country B, there is no basis for country A to trade with country B. The answer is false on that particular statement, and hopefully you understand why. Another way of phrasing that question is, a large country should not trade with a small country because the large country can produce more of all goods than the small country can. And all this relates to what economists call the Ricardian principle of comparative advantage. The way I tell this story to my students is, if I can do everything better than you can, there's no basis for us to cooperate. That statement would be false. What will it cost us to specialize in textile? The answer would be giving up 4,000 units of soybean in order to produce 3,000 units of textiles. Or the slope 4,000 over 3,000 is 4 over 3 with a minus sign. So we would say that the opportunity cost, or the cost of producing textiles in country A, would be the amount of soybeans it has to give up in order to produce those textiles. And because it's a straight line, I can easily use the corner solutions. So the opportunity cost of producing textiles is what you have to give up, 4/3 of a unit of soybean to produce an additional unit of textiles. In country B, you give up 800 to produce 1600. So the answer to the question, what's the opportunity cost of textiles in country B, would be 800 over 1600, which is 1/2 of a unit of soybean. As you look at these two numbers, the 4/3 and the 1/2, 1/2 is clearly less than 4/3. So we would say that in country B, the cost, drop the word opportunity, the cost of producing textiles is much lower than the cost of producing the same textiles in country A. If you find out there's somebody who can do something you want done better than you can, you should want to beat a path to their door. The opportunity cost of producing textiles is lower in country B, half a unit of soybeans given up, so everyone would want to purchase their textiles from country B. But notice country B cannot produce the quantity that country A requires. If we were at the midpoint, country A wanted the 1500, country B could produce the 1500, but it would only have 100 left over for its residents. So we're going to say that because country B is small and it cannot meet the demand in country A and the demand in country B, what's going to happen is that country B will specialize in producing textiles and country A would remain diversified. It's going to produce some textiles and mainly soybean. So if, for example, we said that the total demand for textiles was 2,000 units, because country B doesn't have the physical capacity to produce 2,000, then country B will do the best it can, and then country A would have to make up the difference. So country A would have to continue to produce some textiles, for example, at a point such as this, which means that it would produce not 4,000 units of soybean, but some smaller quantity to be at a point such as this. We've just identified an important principle. First, that there's gains from specializing, but even when a country can't specialize, as in the case of country A, there's still gains to be had. That incomplete specialization or the lack of specialization by a country such as country A does not deprive country A of the benefits to be had from international trade. As we did earlier, you would see that Mexico's labor force of 100 million, the unit labor requirement in manufacturing is 5, in agriculture is 1, and the analogous numbers for the United States are 3 and 2 for manufacturing and agriculture, 3 for manufacturing, 2 for agriculture. And if I wanted to calculate the maximum quantities of manufacturing and agricultural goods that can be produced in each country, I would have the country specialized. So the US, putting all of its workers in agriculture, would produce 250 divided by 2, which is 125 units of agriculture. Mexico would produce 100. In terms of manufacturing, Mexico would produce 100 divided by 5 is 20, and the US would produce 250 divided by 3, which is 83. The data in this will now be used to plot the production possibilities curve. And what we're going to do is to identify the point 83 on one of the axes, and on the second axis 125. Those two numbers would tell us the opportunity cost pre-trade, the opportunity cost of producing manufacturing goods. Over here we have the data for the Mexican production possibility frontier. So these data would also help us to determine the opportunity cost before trade occurred.